Let's talk about rational root theorem by Descartes. Okay, same mathematician from France, and he talked about rule of signs and rational root theorem. Now he has some idea how many roots are there, and now he wonders what will be the number for that solution. So if I'm doing the synthetic division, what number do I need to put in the half of the box to start with? Can I try all infinite number to try? No, that's not a good idea. So he ends up with several examples and he finds another pattern. So this is his rational root theorem or his rational zero theorem. Possible solutions are going to be the number from division. By doing division, you can have only the rational solution. Rational means fraction looking. Can I have a square root solution from this theorem? No. Can I see imaginary number solutions? No. He's talking about only fraction looking solutions, okay, in the rational numbers. So this is the example. Start with the last number. What's the last constant? 6. So factor 6 and then factor the first number. What is the leading term? The first term is the leading term. Give me the first number from the first term, which is lead coefficient 1. So you are going to factor, and then consider all possible signs, plus, minus. That's how I got all of those. And then divide. This is not a notation for the division here properly, okay? But think about dividing that case, and then your answers for the possible 0 will be the quotient, okay? On your paper, we have the similar one, and let's look at it. And I'm going to highlight those. What is the last number in example A? 10, right? Don't worry about negative sign. We will consider all positive, negative anyway, okay? So start with the 10 and give me factors of 10. 1 times 10, 2 times 5, right? So 1, 2, 5, 10. Include both signs, plus or minus. Turn around, please. Turn around. I'm not going to call your name because I'm recording, but pay attention in class. And give me the first lead number, lead coefficient. What is the number? 3. So give me the factor of 3. What is the factor of 3? 1 times 3 only, right? So I'm going to use 1 and 3 for dividing. So this one has factor plus or minus 1 plus or minus 3. So if you divide all of these numbers by the first case, you'll get the same thing, right? If I divide the last number by the second option, plus or minus 3, you'll have a fraction looking. Yeah, that's fraction. These are the numbers. And all are rational possible solutions. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Plus minus case, double 8. 16 possible cases. So Descartes says we have 16 possible solutions to try, okay? So that was his rational zero theorem. When I didn't have TI-84, when I was your age, this was very important thing. So when I do long division, I have to start with some number, and these are my options to try. So I can use which one will be the solution, or factor, or 0, or root. The next example, factor 36. What are the factors? Oh, so many factors, right? And factor the first number, which is plus or minus 1 only, and then you will have everything by itself again. This is called the rational zero theorem or rational root theorem, okay? Root, 0, those are the same thing. This is by Descartes. And let's do one problem with me, okay? Question number 1 with me, and I'll do one more probably. Question number 5. And I don't have enough space here, so I'm going to use notebook. Okay, if you have your notebook paper, use notebook paper. Alright, first one, I need to start with factors. So let's start with the last number. Last number goes on the numerator, so start with the last number. What's the last number? 8. So factors of 8. Give me factors of 8. 1 times 8, 2 times 4. And let's consider both cases. Positive, negative, positive, negative. Plus or minus, plus or minus. Put commas between the list of numbers. And then let's think about factors of bottom number. Okay, what will be in the bottom? The lead number, right? Lead coefficient, which is 1. So what is factor of number 1? 1 times 1 only, right? And plus or minus this case. So I'm going to do dividing. Alright? Divide two numbers. And every case you will have possible solutions. So let's talk about possible rational solution or rational root or rational zeros. Okay? So this is called the rational root theorem or rational zero theorem. What are the possible rational roots? So I need to do division. Dividing by 1, what do you get? Itself, right? So I'm going to have the top numbers itself by dividing by 1. So that is my possible solutions, possible zeros. So if I have 1, that's easy. I can just consider the last one only, right? Question number 5. I need to consider factors of the last number and the first number. Last goes on the top, okay? You have more options for the number here. Factors of 12 is the last number. And then first number is not 1. Oh. Alright, factors of what? 3. So let's talk about all the factors. What are the factors of 12? 1 times 12. 2 times 6, 3 times 4. Alright, don't forget plus or minus signs. We need to consider negative also as a solution, okay? And then put commas between those. And factor of 3, lead term. Plus or minus 1 and plus or minus 3 is a prime. After that, I need to find what are the possible rational root or rational zeros. So let's consider doing this guy first, okay? I'm going to do this guy. When I do dividing by 1, what do I get? Same thing again. So let me copy down one more time. I'll get the same thing, all of those. Alright, then I'm going to switch color and I'm going to do the second one. Plus or minus 3 will be in the denominator. Wake up. Wake up. Alright, let's do division. So first number will be divided by that number. So I'm going to have plus or minus 1 on the top, 3 in the denominator. Do you see it? Okay. 1 on the top, and then 3 in the denominator. What will be next? 2 on the top, 3 on the bottom. That's right. Plus or minus 2 on the top, 3 on the bottom. Plus or minus 3 on the top, 3 on the bottom. Plus or minus 4 on the top, 3 on the bottom. Plus or minus 6 on the top, 3 on the bottom. Plus or minus 12 on the top, 3 on the bottom. Right? So all solutions look like fraction. Rational solutions, okay? And did I say something once again? What is 3 over 3? 1. So can I cross out? Because I said already up there. Any number is repeating? 6/3. What is 6/3? Plus minus 2. That's right. I have it already there, so I don't need it anymore. Another one. 12/3. That is 4. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 cases with plus minus. So I will have 18 possible rational zeros, okay? Does it make sense? So that was his idea. Okay, I need to come up with some possible solutions. These are the possible solutions. So picking number from here, I may see remainder 0. And by using the factor theorem, you can find the solutions.